In this video, we're going to be starting section 11.2, Arithmetic and Geometric Sequences. So we're looking at number patterns again, and this time we're going to be looking at arithmetic, which is a sequence of terms that have a common difference. And so one term equals a constant added to the preceding term, and so that D is going to be referred to as our common difference. In geometric sequences, one term equals a constant multiplied by the preceding term, so we call this a common ratio. And so these are the two equations that we're going to be using. And so the first one we're going to be using here is the a sub n in both of these. And you're going to need to refer to those, and they are also on your worksheet. So, are the following sequences arithmetic, geometric, or neither? If they are arithmetic, state the value of D, and if they are geometric, state the value of R. 6, 12, 18, and 24. The number pattern that we see here is that each value is 6 more than the next. So this one is arithmetic, and our D is going to be equal to 6. 6, 11 to 17. Well, 6 to 11 is not quite 6, that's 5, and 11 to 17, but there's really no number pattern there that we can figure out. It's not a difference or a ratio, so that would be neither. Letter C, 2, 14, 98, 686. Numbers start to get very large, so that's indicative that this could be a ratio. So if we take 2 to 14, 14, 98. So it looks like if we are multiplying and that one term equals a constant multiplied by the preceding term, it must be a geometric sequence. And in this case, our ratio R is going to be 7. 160, 80, 40, and 20. Each of those values go down by 1/2. So if they go down by 1/2, this is going to be a ratio. So R is equal to 1/2. Negative 40, negative 25, negative 10, and 5. This one will be arithmetic. Each of those values have a common difference of a positive 15. Now letter F's a little bit weird. 7, negative 21, 63, and negative 189. Notice the values go from positive to negative. And so this is another example of having a ratio. So this one is geometric, and that ratio is 3, a negative 3. And so that's because 7 times negative 3, negative 21, so on and so forth. So let's focus on arithmetic for a minute. So arithmetic sequences, we can use that equation from above that I've already written here for you to find A and D and then state the final formula for the general term. But we always want to make sure we simplify as far as we can to make our lives easier. So negative 10, negative 4, 2, 8, and 14. A is going to be equal to our starting term, which in this case is a negative 10. Our difference, our D, if we look here at this number pattern, is a positive 6. So we're going to take those two values and put it into the original equation. So A sub n equals negative 10, which is our A, plus, in parentheses, 9 minus 1 times our D, which is 6. Go ahead and simplify. We have negative 10 plus 6n minus 6. And simplify one last time. A sub n equals 6n minus 16. And that is our formula for the general term. And that's as far as you have to go. Next problem. 10, 8, 6, 4. Our starting value is a positive 10. And our difference, in this case, is a negative 2. Make sure you watch your signs here. So when we go ahead and put that into our starting equation, A sub n equals positive 10 plus n minus 1 times a negative 2. Go ahead and simplify. We have 10 plus negative 2n plus 2. We can simplify one more time. A sub n equals a negative 2n plus 12. And if we wanted to, we could plug in a value there to find the number in the sequence, which we're going to do after this next one. So we have 36, 31, 26, and 21. A is equal to 36. And our difference here is going to be a -5. So we're going to go ahead and plug those into that original equation. A sub n equals 36 plus n minus 1 times a -5. A sub n equals 36 minus 5n plus 5. We can simplify one more time, and we can simplify to -5n plus 41. And so we're going to use this one in the next problem. So the next type of problem will say, hey, use the formula that you just found to find the 7th number in this sequence. And they're going to do that by asking you to find t sub that value. In this case, it wants us to find t sub 7 in -5n plus 41. So we're going to plug that 7 in for that n. And so when we plug that in, it will be t sub 7 equals -5 times 7 plus 41. And now you just need to watch your signs. And -5 times 7 is a -35 plus 41. T sub 7 is going to be equal to +6. And the next one, it says find t sub 20. Easy enough. So we're going to take t sub 20 equals -5 times 20 plus 41. That's -100 plus 41. So t sub 20 is going to be equal to -59. So that means in that sequence, the 20th value is a -59. So let's look at geometric. So in the geometric, it wants us to find the formula for the general term, which I've already written on here for you from above. So find A and R and state the formula. In this case, we have a 1, a 3, a 9, and a 27. A is equal to 1, and our ratio in this case looks like it's a 3. So when we plug that in, we'll have A sub n equals 1 times 3, all raised to the n minus 1. Next one, 12, 6, 3, 1.5. That, to me, looks like we're going down by 1/2. So our beginning number is 12. Our common ratio is a positive 1/2. And we're going to plug that into that equation. A sub n equals 12 times 1/2, all raised to the n minus 1. And the last one of these, a 9, a -3, and a 1. So, our beginning value, our A is 9. And again, we have a ratio, only this time it's a negative. See that negative on that 3? So this ratio, D is equal to -1/3. And if we plug these into our equation, we have A sub n equals 9 times -1/3, all raised to the n minus 1. So now, same thing we did with the arithmetic. For the geometric, it wants us to use the formula above, the one we used here, and go ahead and find some t values, the number of sequences. And so we're going to go ahead and plug that in. So if we use our original problem here, we have A sub n equals 1 times 3, all raised to the n minus 1. The first one it wants us to find is t sub 4, so we're going to plug 4 in for n. So 1 times 3, all raised to the 4 minus 1. And I'm going to show each step here so you guys don't make a mistake. 1 times 3, all raised to the 3rd power. 3 to the 3rd power is 27, so t times 4 is equal to 27. And the very last one, it wants us to find the 12th number in the sequence. So t sub 12 is equal to 1 times 3, all raised to the 12 minus 1. That becomes 1 times 3, all raised to the 11th, and you will need a calculator for this one, and that will be 177,147 is our value for T12. That means the 12th number in this sequence would be that large value. And the next video, I'm going to show you how you can find number terms, the total number of terms in a sequence.